Okay, here we go. All right, let's look at this one. This is one of the kinds you guys wanted, right?
Yeah.
Okay. Use trapezoidal rule to approximate the following definite integral for the given value of n. Okay, so for one like this, then this is one. Kayla picked out two good ones. If you look at what she had up here, these are really the two kinds of trapezoidal rule approximations you're going to do. A small one, right? It's really small, and then a big one where you have to use sigma notation. On one like this, which we can go through, you don't want to. You just do it manually. You're just going to figure out what the delta x is, and you're going to use the manual version of the trapezoidal rule formula and literally just add the terms up and get an answer. One like this, though, we can't do that. One like this, we've got to use the sigma formula.
Got it.
So that's what?
What is that?
B minus A over 2n.
A sub TR? What is that?
Trapezoidal rule.
Oh.
So B minus A over 2n is the multiplier. And then remember that we had f of, I don't know what you guys want to call this. I always call it f of A. But if we call it, we can either call it f of x sub 0, which is the same thing as A, plus f of x sub n, which is the same thing as B, plus 2 times the interior sum, right? So the interior sum is the sum of f of A plus I delta x from 1 to what? 5. No. Just in general, if we have n divisions, it's always going to be 1 less than n, so n minus 1. It's just the interior sum, right? So we're not going to. Notice that x sub 0 and x sub n they're outside of that sum. So we're only adding up. And what this really is right here, we're adding up f of x sub I. That's all that stuff is, right? Is x sub I from 1 to n minus 1. Okay. But we don't need to think of it as x sub I here because we know what those are. That's A and B, right? Those are just the endpoints of the area, the left boundary and the right boundary. Okay. So now that's what we always start with. That's never going to change. We have to plug in the specifics for our problem into that, right? So what are our specifics then? Let's write those down. So what's our A? There's the integral that we're approximating. 2. That's just the lower boundary of the integration, right? So A is 2. B is 5. And N is 77, right? So then we can, right? So then we can take all that stuff and calculate delta x. So what's delta x? Right, delta x is just always b minus a over n. So what do we get? 3 over 77. Okay, so there's delta x. And then we also want to take into account, so there's part of it, what is f of x for us?
Oh, 4x.
Yeah, 4x squared plus 4, right? Okay.
Yeah.
Okay, good. So then we're going to take this information and plug it into this function to represent all that stuff, right? So what's that going to look like? Let's take this thing right here and see what that's going to look like. So f of a plus I delta x is f of 2 plus I times delta x is just 3i over 77,
Yeah.
right? Okay. But f of x is 4x squared plus 4, right? So that's going to look like 4 times that quantity, That's x, right? F of hand is just 4 times hand squared plus 4, right? Okay. Right. So that's the stuff then that goes up there. So now we've got everything we need to rewrite our trapezoidal rule approximation for our specific area that we're approximating, right? So I'm going to take that whole thing up there, I'm going to copy it and put it down here, and then we'll plug in all the stuff. This is why I'm making big bucks. Look at that. All right.
That looks like a fish.
I was gonna say shark. I know.
Okay, so there's what we're plugging in for, right?
Yep.
Okay, so let's do this. So we get b minus a over 2n. So we said that was 5 minus 2 is 3 over 2 times 77, right? So I get 3 over 154. Oh, that's not right. 77. Is that right? Yeah, 154. That's right. Okay. Okay, so times f of 2, right? X of 0 is just a, which is 2, right? So what is our function evaluated at, there's our function. What's f of 2? Yeah, 4 times 2 squared, right, which is 4. So 16 plus 4 is 20, right? Okay. So that whole thing becomes 20 plus f of 5. So 4 times 5 squared, so that's 100, right? Plus 4, 104. Okay. Okay, no, let me do that again. Where did I get the 20? Because we're calculating, there's our function, f of x. Here, in fact, let me write that bigger down here. So here's f of x. F of x equals 4x squared plus 4, right?
Okay, I think I see what you're saying. Okay.
So I'm just evaluating the function at 4.
Okay, I got you.
Does that make sense? And so then we found that f of, oh, I'm sorry, that was f of 2, wasn't it? Not f of 4.
Yeah.
F of 2 was 20, and we found that f of 5 was 104. Okay? So that's how we get those two numbers, plus 2 times the sum of f of a plus I delta x. Well, we said that was just right there, wasn't it? Yeah. Right? So all that stuff just goes in there. Right? So the sum of 4 times the quantity, 2 plus 3i over 77 squared plus 4. Okay, and the sum, right now, what's our sum going to go from? Our sum goes from 1 to, what is n minus 1 for us? 76. Good. Okay, and now we'll just let our calculator do all that stuff for us. Okay, so we want to put that whole thing in our calculator. All right, so we'll go to the next page for that. So, copy that to the next page. It's just an excuse for me to be able to make another awesome shape.
You don't want that line.
Oh,
Looks like a fish.
oh, I didn't want that, did I? Oh, never mind. Sorry.
What's the sum deal?
It kind of looks like that.
You go.
Shot.
Oh, not 0.
Look like it now.
Nope, zero.
Oh, that's true. Man, good job, Robin.
Oh yeah, why don't we just plug in the original equation in the calculator?
The original, well, because the original one, what's it going to do with that? There's too many unknowns. If we see, now notice all we've got here, the only variable in this whole thing is what? I. Yeah, it's the index variable. So then let's grab our calculator and put all this stuff in.
So you don't want that I equals one, right?
No, you're right. I don't want that I equals 1. Let me get rid of that.
Just draw y.
What do you mean, the original equation has one there?
No, it doesn't. It has f. We don't know what f is. We don't know what x is. We don't know what delta x is. We don't know what a is. We don't know what b is. There's a ton of stuff in there. We got to be able to plug numbers in. So when we put this in our calculator, the calculator can give us a numerical answer. Right? So now this is an important question. Let me make sure everybody understands why. The question was, why couldn't we just plug this in?
Not that.
Oh, not
one
that.
before it.
Which one?
No,
The original
yeah.
equation.
Just the question.
Oh, this?
Yeah.
Well, you could, but the point of this, if you get the right answer is the wrong answer on this question.
It
You
doesn't
want
work.
this?
No, if you give me the right answer, it's going to be wrong because the whole point of this question is this happens to be one that we could do. We could do using the fundamental theorem, right?
I'm good at getting it wrong.
But we're practicing a technique. Hey, we're practicing a technique here that allows us to get a numerical approximation of a definite integral that can't be integrated, right? And so if we pick arbitrarily, if we pick n equals 77, that's going to give us an approximate answer that's not perfect, right? And so what I want from you is that imperfect approximated answer. I don't want it'd be easy on a graphing calculator test to just ask for the right answer from your calculator, and it would give it to you. But that's going to give you, it'll be marked wrong because it's too good. It's better than the approximation I'm looking for, if that makes sense. Okay, so now let's do this on a calculator.
Let's try to do
Here, this game will take 5 minutes.
No, this won't take long at all. This is no big deal.
No, just
Okay,
the
I'll watch
one.
the clock.
I'll watch the clock.
I think I did my math wrong.
Okay. So when are we starting with this?
Right now.
Okay.
We started 2 minutes ago.
Okay.
Yeah, I did my math wrong. So
Okay, so
On there? Well, let's see.
So when it goes to third.
All right.
Oh,
So
wait, I have a question.
Yeah.
Can you go to the previous page?
I can, but time's off. I made it.
What? No. No, when you get the answer.
Oh, okay. All right. Yeah, previous page. Gotcha.
Wait, you gotta minimize that, yeah.
This doesn't count as your time.
No.
That's right.
Yeah, that's it.
No.
Yeah, that's how time works.
No.
Anyways, when you go down to like the bottom.
Pretty simple. Did you do the square?
So is that a 104?
Yeah.
And you got that because
I just plugged in. I plugged 5 into that. 4 times 5 squared plus 4.
100.
and because 5 squared is 25.
Yeah.
He's just slowing you down.
And I have
Yeah.
another question. I have another question.
Okay, let's
Yeah.
The 2 is always 2 at the end, right? Did we times the whole function by?
This?
Yeah, that's
Yeah,
always
that's
2.
always there. Right. That's part of the
Why is that
formula.
always
See,
there then?
right there.
Why?
Because that's the equation.
Okay.
That was a legitimate question. I don't,
It's there because that's the interior sum, and you're double counting the edges of those partitions is really why. Okay, so let's add this up then. So we're just going to take 3 over 154,
do the
So-
alpha.
3 divided by 154 times.
Yeah, you want.
It doesn't matter. This knows order of operation. It'll do that division first and then the multiplication. I could, it wouldn't hurt. It'll work. Times in the quantity, so in parentheses.
Wait, how do you put that in the calculator? The
But
squiggly
please excuse me, dear Aunt Sally, would be the times first.
No, that's not true. It's multiplication and or division. They're equal.
Wait, no, wait. Look at the
Well, then
equation.
we were taught
The
wrong.
parentheses you have there is
exact
squiggly.
thing last time.
What the parentheses you have there is squiggly. So how do you?
Oh, no, don't be doing that. Come on. Okay, I give up. I didn't make it in 5 minutes, but we're done with it.
No,
We're not
So
done yet.
20
Still
plus-
2 minutes.
104 plus 2 times, and now we need the sigma. So we go math
0.
9.
0
So
gives me, does it?
Wait.
Yeah, there it is. Okay, math 0. And that gives me the sigma.
Do you plug in X, Brian?
Yep. Might as well. It's easier. It's one button. So X
Sorry, go.
from 1 to 76, right?
Yeah.
Of this whole thing. Now we got to put in all this stuff in terms of X, though.
What is it, 77?
No, it's 76. You took one off.
It's n minus 1, remember, in the formula? Okay, so then we're going to go 4 times the quantity, 2 plus
Gotta do alpha.
3, I don't know, do that,
Yeah.
plus,
Alpha what? That's better.
all right,
Alpha.
alpha F1, get the little fraction.
1.
2 plus the quantity,
3
3x,
or X.
divided by 77. Okay, now I got to close that little quantity and square it. Whoops, I got one too many.
Oh.
Okay. So we got to put the parenthesis, or the, close that set of brackets, square, plus 4. Now I got to close the parentheses on, which I guess are right there, right?
Yeah.
Okay, so there's the parentheses for the sigma, and then I got to put parentheses around the whole thing, right?
Right.
Because I've got the whole thing. Remember, this whole thing is being multiplied by 3 over
Yeah.
154. Now, sometimes what I do is I'll create that second set of parentheses right at the beginning and just fill stuff in. It's easier to do on a TID9 though, because this one defaults to overriding. So anyway, so put in last set of parentheses, and that should be it. It's going to think for a second. Yeah, it will. It's a thinker.
Now you're true.
Yeah.
Okay, I got something. I got 44,000.
Yeah, we made it in 5 minutes.
Okay, if you got 44,000, you're a little off.
Oh, you made
31.
you made
We
time.
started at 6.
Oh, you made time.
Made time, all right.
Made time. You made 5 minutes.
Okay, so now they wanted this rounded to how many places?
4.
Okay, say it was 4. So our answer then was to 4 places was 168.0030, right?
You don't have to put
Okay.
that 0.
No, we don't. I don't. So now, if we want to get the actual answer, just to compare, we can do that pretty easily. All we have to do is there's our original problem, right? So we could just do math 9. Is that right?
Yeah.
Math 9, and we're going from 2 to 5, and it's the quantity 4x squared plus 4
Are you in the remote?
dx, and look at that, 168. Pretty close.
Usually, yeah, it's usually off.
0.003 off.
Yeah.
Is that what you want to say?
You want to see the calculation?
How big?
Okay, so let me go up here. So you want to see it on here, you mean?
If you just yell her
Well,
out.
there's a couple of them.
I'll tell you what, I think I can print it out. Hang on. I think there's a really cool way to do this. If I go Tools,
Yeah, I'll take a screenshot of you.
View,
Actually, I might. No, I didn't. Nope.
File frame. Change it to blue. Shouldn't you
File
still
frame.
equation, window. That's not okay. I don't know what to do. So here it is. How about if I just write out the keystrokes?
Sure.
Okay.
Why did you put it in? Don't know why. There's so many things.
There's the key. Does that help? There's the key history.
Oh, gosh.
I'm kidding. Okay, so let's.
No, really, this is it.
Okay. No, really, here.
Okay, so was I on the next page up?
Yeah.
Okay, so how do we do this on the calculator? You would do this. You would just say 3 divided by 154 times parentheses
20 plus 4 plus 2.
plus 2, and then this can be hard. Then we got to do that sigma. Right. 2 times sigma x equals 176, and then parentheses. And then in the parentheses we've got 4 times quantity.
Plus,
What was it?
2 plus 3.
Is that what it was? 2, yeah, okay, 2 plus, we did that, 3x over 77 quantity
No, it's 77.
Right there.
Squared.
76.
And then,
squared
hold on.
Okay. plus 4, yeah, is that right? Plus 4, yeah, okay.
Oh, Jesus.
So that's it, yeah, that's what you're missing, I think.
Plus 4.
Then we go plus 4, close the parentheses, that's for the sigma.
Then another.
And then we need another set of parentheses.
I don't think the extra parentheses thing really does it. I think it'll still calculate.
Okay.
Probably would.
So
that's
squared
it.
plus.
That's what you should have.
plus
Yeah, that we've gone over that twice. We'll go over that.
Yeah.
Now, are you gonna do like small ones too?
No, just hold on. I have it.
This way.
Okay.
Mr. What's the difference between like small and small ones?
Okay, so we do, what do you want to do, a small one?
Yeah.
Okay. Okay, so let's do a small one. So let's go back, I'm gonna go back to the, did you get it, Ethan?
No, just a second.
This calculator's messed up.
I'll print that out at the end, so you can have it. Okay, so let's look at the next one here. So if we go, yeah, there's one, n equals 5,
Oh, wow.
okay? So let's do this one.
There, syntax.
You've done something wrong.
You think, Dad?
Yeah.
Good
Fix it.
assumption. Your assumption?
Fix it.
Wait, so since the n number is really small, it's going to be way off from the.
Yeah.
Yeah, it'll be way
Wait,
off.
so if it was like 77, then you could just input
I
the.
still got 44,000. I have no idea.
I'll look at it in a second.
Okay, it's not that big of a deal.
Okay, so now on this one, we're just going to use, Kevin, take a look, please. Okay, on this one, we're just going to use just the regular manual formula, which just looks like this. So the trapezoidal rule, this area is approximately b minus a over 2n times f of x sub 1, or 0, sorry, x sub 0, plus 2 times f of x sub 1
Mr. I have
plus f of x sub 2.
Mr. I.
Yeah.
So you know how in the calculator you can store a number to be like x?
Yeah.
Then how come when you did your calculations just now, it didn't use that number for x?
Because it stores its own number. It stores a local variable in there that it uses if it needs to.
So how does it know you want it to be x instead of the number you stored?
Once you go to math and select that function, it's in there.
You're entering stuff that's stored as part of the algorithm it uses. You're entering local variables that it's using. I don't know what it calls them, but
Did you get it?
No, this is a small one. Fine. It's the same concept, but it's complete.
Only because she gave us that.
okay, right? So there's, everybody see that? So there's, how come it looks like that? Because n equals 5, right? So does everybody see what we did there? We've got this multiplier out front.
Hey, look.
Okay, you want to see this one?
How come
Yeah,
the last
multiplier
one
out front, you've got the first term, f of a, plus 2 times the interior sum, which this time is only going to have 4 terms, right? Yep.
Why'd you put that at the end this time? Does it matter?
Well, just, it doesn't matter. Doesn't matter. But when I write it this way, then you know that you're just going in order, but I double count all the middle ones. So the first and the last, you don't double count, but everything in between, you do, right? I'll tell you later. The reason is because I said this before, the left edge of the first or the second interval is the same as the right edge of the first interval, right? When you're calculating the area of a trapezoid, you're using both heights in your calculation.
So
Right.
how come we didn't do that for the last?
Because when you for rectangles, because when you're calculating the height of a rectangle, you only need one side. You don't use both parts.
So we're gonna-
We are. That's why we have a 2 there. That's what the question was. Yeah. So let's go through this one. So then for us now, what's A, what's B, etc. Okay, we know for us that A is 3, B is 9, n equals 5. So what's delta x?
Why didn't you just do it the other way?
6 over 5. Exactly.
Why do you have to change it up?
What's that?
Why do you have to change it up? Why can't you just do it?
You can, but it's probably easier this way. You could. But it's probably easier to do it this way because there's just such a small number of terms that just calculating the values of those terms is pretty simple. Right? So then what this looks like.
Yeah, it's over 2n.
Yeah, it's over 2.
No. Delta x is b minus a over n.
Oh, yeah.
Right? That's a formula that didn't change from before. Delta x always equals the width of the interval. Think what we're saying. That makes sense. We're taking the whole width of that interval, that area, and dividing it by the number of pieces we're cutting it into. Right?
Yeah.
So b minus a over n. So our delta x then, delta x equals, what did we say it was? 6/5. Okay, now, let's plug in our stuff in. So we get 6 over 10, which reduces to 3/5, right? Times f of 3, right? Plus 2 times f of 3 plus delta x. 3 plus 6/5. Well, what is that? 15/5 plus 6/5 is 21/5.
Wait, 3 plus what? Delta x.
Yeah. We're just walking over in steps of width 6/5. Okay? Let me see what we did. That's x sub 1. X sub 1 is just that, right?
Why?
Yeah, why?
Why? Because it's a plus I delta x, right? So it's a, which is 3 plus
Okay.
1 times delta x.
Got it.
And that's all we're doing is we're just taking steps of width 6/5 each time. That's how much the x value is changing for each calculation, right?
So that's a plus I
Well,
delta x.
say it again.
That's a plus I delta x.
Yes.
Okay.
Yep.
What's I?
Shane Wagner.
What?
Immediately.
To who?
No, Lee.
What's
Just,
I?
just in case, bring your stuff.
What's,
I'm sure you'll be better.
What's
I
I?
don't know. I don't even know idea.
I,
I is the index variable. This tells you which one we're on. I is going to go from 0, which is the left edge, up to
So
5.
x is 1 and I is 1.
Yeah.
Okay.
Right. So this is in other words, this is just keeping track of how many times we've added delta x. How many steps have we taken? Okay. So plus f of 21/5 plus 6/5 is 27/5, right? Plus f of 27/5 plus 6/5 is 33/5. Plus f of 33/5 plus 6/5 is 39/5.
21/5 is
Yeah, 15/5 plus 6/5, right?
Yeah.
Okay. And then that's the interior sum. That was x sub 1, x sub 2, x sub 3, x sub 4. And so then we add f of,
5 or 9.
is that not making sense?
I get it.
Okay. Does it make sense? Tanner, make sense? Lane, not making sense? Okay, let's go up a little bit. See, all we're doing is, this is A, right? This is A.
Yeah.
Okay? This is just going to be A plus delta x. This is just going to be A plus 2 delta x. A plus 3 delta x. A plus 4 delta x. A plus 5 delta x gets us all the way to the edge.
Wait.
Right.
That's just because that's just how it is.
That's how it always goes. Remember, we've always had the formula x sub I just equals A plus I delta x. So x sub 3 would just be A, which is 3, plus 3 times 6/5. Right? Okay, and then we get to the last one, which is the very edge of the interval, let's just check to see that
So
it
we
comes
can
out.
Keep adding 6/5.
Exactly. And so this should turn out to be, when we get to the end, it should turn out to be 9, right? Well, let's see if it's better or we made a mistake. So 39/5 plus 6/5 is 45/5, 9. Right? Okay. Now we can do this in our calculators because this is where we can take advantage of maybe the table. Okay, we're gonna plug in. Well, actually, the table wouldn't be good. We'll take advantage of that that deal where we can store values as x, right? And then plug them into an expression. So every time we know what f of x is just 2x squared plus 8, right? So rather than going through and calculating these all manually, we could even take advantage of the calculator's ability to do this real quickly. We could just plug in.
Gotta go down.
Send your question.
Okay, so we could put in, what was it again? 2x squared plus 8. So 2 times x squared plus 8, enter. Okay, and now we can start storing values in there. If I want to know what that number is right there, I can just go 3 store x and go up to that expression, and it's 26, right? So let's write that number down. So then we get 26 for that guy. What's f of 21/5? Well, let's put in 21/5. 21 divided by 5. Store as x. And I can just go up to there and hit enter to grab it. And it's 43.28, right? So that guy is 43.28.
So every x goes into the top equation for every single one of those?
Every single one of those. Yeah, right. We're see what I'm saying?
Yeah.
Okay.
How do you unstore? Make it.
You never have to because there's no reason to. It'll store right up the top of it if it needs to. When you're done, just leave it be. So then we'll put in, what's our next one? 27/5. So same deal. 27 divided by 5. Store x. Okay. Store x. There we go. And then we'll go.
On the computer, this one takes a long time.
Really?
They're slow to the calculator.
On this one, it does?
Yeah, like compared to ours.
Oh, this one, I don't know. I'm not sure. Because it's an emulator, and so it's yeah, I don't think it's as efficient.
Why can't you just store the equation instead of doing everything else on the
What do you mean?
Well, isn't there a way to just store the equation?
I did. I mean, well, I could store it as a variable, yeah. But then that would just save me having to hit up 5 times. Grab it. So then the next one is 33/5, is that right? Yep. Store x is a little tedious, but you get the idea. Okay, 1, 2, 3, 4. So what's this one? 95.12. Okay. And then last 39/5. At least for the hard ones.
Not last.
Not quite last. Oh.
What was the math? Really?
What's the 66 one?
66.32. And then this one is 129.68. And then finally, f of 9. Let's just do that one manually.
91. Or not.
190, what is that? We get 81 times 2, so we get 162, 170, yeah. So this one's going to be 170. Okay, so now we can just add all that stuff up. So we get,
Now we can't just.
so we get 3/5, so 0.6 times the quantity, 26. Let's add this one too. 26 plus 170 plus 2 times the sum of all those weird decimals, right? 2 times, want to read them off for me? 40, what do we get? 40, 43.28 plus 66.32.
I can't read
Plus
95.2.
plus
149.68.
okay, so we'll close that interior sum, right? We added 2 times all that stuff. Close the other sum. Enter. And
No.
No,
oh, I actually added it up here so I could. Yeah, I added it out of order. So our answer is about 518.88. Okay.
Not do it.
Should we see what it really is? Okay. What is it really? It is math.
No.
Ooh, that's so small.
It's 518.8.
That's better.
Math 9 from 3 to 9. It would be big. That seems reasonable.
What's part of the times two?
What's that?
The 171 is part of the times two.
No, we put it before it. So.
Yeah, right. I made sure it was before the times 2. Yeah. Plus 8 px, and it's 516.
Why do we just have to? Oh, yeah. Do we have to memorize this equation? Like,
No. Yeah, no.
I like the AP test.
No, they'd give it to you, I think. I think there's a sheet.
Yeah.
Okay, does that make sense? Okay, of the two, I honestly think that's probably harder. I mean, I don't know, if you want to, if you're really used to using the sigma stuff and you like that better, just use it. It's fine. Even for small numbers, if you want to, you can.
I felt more comfortable.
No, it
with the first
won't. No, you would do the same thing. It would work, of course. I'd have a really small number of n. N would just be 4 or 5. So my sigma's only adding up a few terms.
So where would you cut it off at? Like if it was at like 12, would you go?
I'd say 6 or 8 is high as I feel.
Okay.
Yeah. In fact, I probably wouldn't mess with 8. I'd probably use sigma for 8. Okay. How we doing? 4 minutes. 4 minutes. Let's see what we got here. Okay, so yeah, this is easy, right? I mean, that's just that's just math, 0, plug in stuff, right? Do you know where an exponential function is on the calculator? Okay, let me show you. Let's do this one. So this one, all we're doing for this guy
Is E just a natural number?
is math 9. Sorry, not math 0, math 9. And we're going from negative 1.5, is that right? Yeah. Negative 1.5 to positive 1.8. And then the function is e to the 4x minus 3, right? So that's e is going to be
It's under, or
right there.
over
Right there? Yeah, so I'm going to go second, natural log, and I get e to the what? So it's going to be 4x minus 3, plus negative 3. So
Is that 3.0 or
3.0. This must have been one that I made, or it would have said mine. So x, and then that's it. Okay.
That's it.
Is E just 2.5?
Yeah. Okay. Right. So we want to go through probably one of these, right? No, not today. But then we want to go through one of these where you find n.
Yeah.
Yeah.
That one.
Right. Okay. So we'll do that. That's the first thing we'll do tomorrow. We'll do that one, and then this one right here is actually really simple because they're giving you all the numbers. This one we can do in 5 minutes. The other one takes a little longer. No,
Yeah, we did that one in like 4.6, I believe.
Yeah, that one's super easy.
yeah, this one is pretty easy. Yeah. All you're doing here is giving you, that's f of x of 0, that's f of x of n. And so you're just saying, all you do on this one is b minus a, right? So 12 over 2 times 6, 12 over 12 is 1, times 12 plus 16 plus 2 times all that stuff. All those y values. That's it for that one. We can look at that tomorrow real quick.
Well, on the problem that you just did, was E just